Hello everyone, it's another video with Dr. Edward Santiago. This is the Module 2 lesson. We are going over the second chapter of your textbooks. Hopefully that everybody has is the physical layer, cabling, and twister pair. Okay. All right, so we have benefit of doing this online is that you could fast forward, rewind, or do anything you want to do, watch it as many times as you want. And pause it and do whatever you have to do and continue watching later. So, few benefits to this uh, way of doing this course. All right, so let's start talking about what Electronic Institute of Alliance is and Telecommunication Industry Association, uh, what they do. Basically, they create the standard for constructing cabling and telecommunications equipment. So those are your standards. So when you see on the cable, you're going to see this right here, TIA EIA 568A. Depending on the version or the year, you're going to see different versions here. We're going to go over that in a bit. So the most important thing, important addendum to the EIA TIA 568A standard was addendum 5, which was published in 1999. Okay, these are just publications that dictate the standard of the cable. The addendum defined the transmission performance specifications for 4 pairs running at a 100 ohms category 5E twisted pair. This is the type of cabling recommended for use in today's computer networks. Actually, Cat 6 is the currently being used, and 7. However, in Europe they're up to 8. It's it's weird. So it's just marketing. If it continues to sell, they will continue to sell. Hold on to the last category, and if it works, don't fix it. So that's technically uh, the idea behind why we're still running a little bit behind. All right, so is the standard defined minimum requirements for the internal communications wiring in buildings between structures and the campus network. All right, what is a campus network? It consists of interconnected LAN. So each building will have its own LAN, and then how to connect them uh, among themselves. And this is, you're going to see this in universities, building complexes that or government agencies. You're going to see that have multiple and nearby buildings that they're going to be considered campus area networks. All right, so here's a B, which is the kind of the newest version. So it goes over section B1, 2, and 3. Goes over commercial cabling, twisted pair media, and fiber optic. There's 6 subsystems to the structure of cabling system, and this is where you need to visualize and that you might see that it's one whole network, but there's a lot of components and subsections to a network. Granted, if it is a small organization, you're not gonna see as much as this, but you're gonna have all these components, except for the backbone probably, because backbone is used to interconnect closets and equipment rooms and so on. So that cable is considered your backbone. If it is a small operation, most likely you're not going to have a backbone. But if you have more than one floor, more than one building, you will have a backbone. So you have, this is divided into different sections. So every building is going to have an entrance, no matter an entrance to the building. That part is set up is where you shake hands with your internet service provider. And in many cases, you have to, if it is a new building, you have to design the entrance. It might be over the air. It might be a hanging wire or cable that comes from a utility poles, or in most cases, when there's big buildings, you're gonna have to design. Uh, before you do that, you have to contact your service providers. In this case, might be um, Spectrum or any other service provider that you have. They would tell you how where their cable or their services is passing by. Based on that, you're gonna make a design where you're gonna lay either a 6-inch type 6-inch pipe that is going to be buried, that is going to go right into your service room. Okay, based on this is again, this is thinking and that you are participating in a project where you're building a new building, new facilities. That's what we're talking about. Now, if you are coming into a new facility, what already existing facility, what you would determine is where how you're going to locate your facility within the building according to where the entrance is. So all these things uh, have you have to assess where the services are coming in. So based on that, you will determine how you're gonna locate your equipment and so on. How you're gonna what topology you're gonna use, and how you're gonna interconnect all your computers and departments and whatever. So what I'm trying to say is that there's different layers to your computer network, and the interest facilities is one of the most important one. Certain details that you have to be aware of, and it is that the service cable that comes in from your service provider cannot be in the building more than 10 feet. It's toxic. It's considered toxic. Um, that might change over the time. Depends on the type of cable, the type of service you're getting. So just be aware of those little details. You also have an equipment room, which is the room we're set aside for complex electronic equipment such as your network servers and telephone equipment. There's have many names, and some places might be the server room, equipment room, so on. And then you have the backbone cabling that interconnects your buildings and floors. Um, and then you have your wiring closet or telecommunication closets, which is your cabling. The backbone connects all these closets. So it's going to be predetermined based on how the working of your organization. Uh, Remember, there's certain limits that we have when we're using twisted pair. So you don't want to go over 100 meters. So we have to take all those things into consideration. And and if you have more than 100 meters between your switch and your user, then you have to probably consider making another wiring closet on the same floor and so on. And because each cable is going to have its different limitations. We're talking for now. We're talking a twisted pair, which it has 8 strands or 8 smaller cables inside, 4 pairs. Okay, we're gonna go look into this. Okay, horizontal cabling is the cable that extends out from the telecommunication closet into your LAN work area. Okay, that's your drop. That's basically we call this, or at least when I was doing cables, we refer to them as drops. This cable might be either fiber optic, depending on the application, or UTP or STP, which is unshielded or shielded twisted pair. Okay. The work area is the location of the computers and the printers where you use patch cords or patch cables, and that's basically where people were working. All right, so this technically, you will be doing these diagrams using DIA. DIA is the application asks you to download. So if you haven't downloaded that yet, please do so. I'm assuming that everybody has a computer and everybody has a Windows-based computer. All right, so you have the entrance to the building, and this is how you design it. And you will have your work areas and your wiring closets and so on. And this is what you're doing this is your main machine closet where you have your servers and so on. And how do you connect? And so this is your planning diagram. You use this to visualize how everything is connected. You can see that you have different buildings. Okay. Uh, Also, you could use this to briefing the upper echelons of your organization, and or if you are contracting new services, they're gonna ask you, "Oh, I need to see a schematic on how the logic of your network is, and or the topology, how everything is connected." So you use this. These needs to be updated as soon as you start adding equipment. These needs to be updated. All right, so the campus um, topology. So this is the main cross connect is usually connects two or more buildings. It is typically the central telecommunication connection point of campus building. So here's everything connects here, is the main cross connect. This is your main computer, so your everything is there. Uh, then you have intermediary cross connects, also called building distributors, and it is a building connecting point of the campus backbone. IC links the MC to the horizontal cross connect, so everything else starts connecting to each other, and until you get to each classroom. Okay, uh, so this is kind of your backbone right here. These cables, usually these are going to be in fiber optic because they have a bigger capacity and they also have faster speeds. Okay. Um, The horizontal cross connect between the buildings are distributors and the horizontal cabling to the network to the work area or workstations outlet. Another term used for HC and the floor distribution plan. Okay. Workstations is where people are working, and typically this is going to be either Cat, not Cat 3, but it's going to be probably Cat 5e or 6. All right. Horizontal cabling is the permanent network cabling within the building, and it's considered to be horizontal cabling. Uh, you don't want to mess around with this. It's basically you want to plan ahead of time, and you want to also make sure that you have enough uh, bandwidth for the long term. There's you don't want to be. Also, these kind of cablings, they come in different colors. So you could color code your network. So you could say, all your horizontal cabling is going to be red. So every time you're digging on your um, the overhead, you see a red cable. That means that it's critical. So use the colors to your benefit. Okay. Horizontal cable, it takes time to plan your horizontal cable installation. Okay. Do not want to redo this. Okay, one thing that again that I stress is you can use the color to your benefit. Just plan ahead. All right, so this is the basic blocks of the horizontal cabling. All right, so that's the backbone cable comes into your rack. These are your racks. This is your switch or hubs. Okay, and this is your patch panel and more patch cables. So this is the drop that goes to your computer. This connects to your switch, and basically what you're doing is you're connecting uh, from the drop to the switch. That's basically what you're doing. Your cable into the network, which is go from your patch panel all the way to the wall jack behind the wall. Okay, that's your wall plate. Then you have a cable patch cord. We call those patch cords, patch cable. Same type of cable that you will use over here. Okay. Now the important thing is for you to know is that from here all the way to here, it cannot be more than 100 meters or 300 feet. Keep that in mind. All right. From your computer all the way to here cannot be more than 300 feet. All right. All right, so this is kind of basically what we did. Let's look at the second presentation. All right, that's two. Let's look at three. All right. All right, so let's talk about a little bit more about twisted pair. All right, so is UTP stands for unshielded twisted pair. There's different categories. The most recent ones that we're looking at. So you have category 5, 6, and 7, which is the most recent one, at least in the States. Okay. So let's look at the performance. The difference between these cables is just how they behave and how much data they can handle. So they certify these cables with different performance. And for example, when we're talking about 5E, you can transmit 1,000 megabits per second or 1 gigabit per second, and it does it at different frequencies. Cat 6 does the same thing, but it does it at a 250 megahertz bandwidth. Cat 6A does the same thing, but at a 500 megahertz bandwidth. All right. Cat 7 provides improved data performance with up to 10 gigabits per second and running at 600 megahertz. Okay. So we're talking about the amplitude, the strength of the signal is what we're talking about. Now, running at 1,000 megabits per second is going to take all 8 strands or eight cables of the UTP cable. Why do I say this, or why do I mention this? Because there's other technologies that are going to be involved with your computer setup, and technologies such as power over Ethernet or voice over IP. These technologies, if you're running a 1 gigabit per second, for example, on power over Ethernet is going to run at 100 megabits per second because it uses the other 4 strands for power. So if you want to run a 1 gigabit per second, you won't be able to do power over Ethernet. Now, there's new technologies out there, and this is every day is changing. You could transmit internet over power lines. That's a whole different animal. Okay? So this is what we're talking about. This is your typical UTP cable as unshielded twisted pair. The shielded twisted pair has a film like aluminum goes over these. It protects your cable. This is a boot, protected boot, and stuff like that, and this is your connector. All right. So the twists, they're twisted. This came around, and I don't know. I don't think none of you, if you're younger than 20 years old, I don't think you're gonna remember this, or at least heard. There was crossover in telephone calls, and you could actually hear your neighbor's conversation. So what they did to fix that is that they twisted the cables and and resulted in a more precise communication where there was less crossover or talk over to the line. So for that reason, uh, cables there has been twisted since then. All right. Be aware because some of these depends on the brand that they might be stuck together, and you're gonna need a special tool to untwist these or to separate these. 99% of the time, or 90% of the time, they're not gonna be. You could do this by hand, so you might want to put some tape on your fingertips because they get sore after you've done 10. All right. Okay. Balance mode. In a balance mode operation, the balance operation of the two wires pairs help to maintain the required levels of performance in terms. Yeah, this is crosstalk and what I just read over that. All right, so this is the different types of categories that are out there. This is the one that came with the book. I got something better than this. I got this from this website. This one tells you the UTP categories from 1 to 7. the speeds for the which they are rated, the distance. This is the, remember I told you that you can't go over 100 meters because you lose the signal, and this is the cable types, what's the pair, and their applications. All right. So go over this. This is pretty interesting. All right. So Cat5 has been around since 1991, since I was in the Navy. Uh, and it is known as fast internet because it goes over 100 megabits per second. This is megabits. Remember, transmission, when you the transmission of data is measured in bits, not in bytes. The capacity in which you store data is measured in bytes. That's your hard drive, your memories, and so on. Communication cards, network cards, modems, and so on. I don't know if you've seen a modem, but telephone modem. These are measured in bits per second. All right, awesome. All right, so they might encounter some performance issues, and in some cases, users on networks of Cat5 are experiencing network congestion because the equipment is going faster than the cable can handle. That's basically it. Uh, it might work, but it's not guaranteed that it will work. Network slowdown is a major concern of computer networks. Files access times, delay, productivity, and effective. Yeah, you might want to take a look at not only the cable but also the configuration of your switches, especially if you have layer 3 switches. You might want to revisit that. Might want to look at your servers as well, especially on a file server scenario. Um, you're supposed to monitor your servers as well, but that's a whole different topic. That's a whole different animal. We'll go over that later on. All right, so Cat5 cabling specification came out by 1999. That's the E, an enhanced version, and it was capable of running at 1 gigabit per second. That's basically it. But again, it does it by using all 4 pairs. Again, if you want to use power over Ethernet, this is not your option. Now, that does not mean that you cannot use 5E, because you can use 5A for anything. Remember, technology is supposed to be backwards compatible. Now, 6. This cable provides even better performance specification, running at 250 megahertz of bandwidth while maintaining a backward compatibility with 5 and 5E. Okay, so if it can run at 250 megahertz, it could run at 100. But if you can run at 100, you cannot fully run at 250 megahertz. It might work, but it's not guaranteed. Now, here's a different version of the cable. Here's a shielded twisted pair, STP. There's certain applications that you want to use this. First thing that comes to mind is hospitals. Hospitals are oxygen-rich environments. So you want to minimize the sparks. So that's where you use shielded twisted pair. Another place is that you want to use shielded twisted pair is when you're going to have interference with EMI, electromagnetic interference. And these are usually going to be next to power lines and generators and so on. If you have to go through these areas, then you might want to consider another technology, or probably a fiber optic cable, which is probably be cheaper and faster than running a shielded twisted pair, because you're limited to 100 meters. Remember that. The shielded twisted pair does not reject all potential interference and noises, but it does greatly reduce the noise interference. All right. So the best option is fiber optics. That's what I would do. So when you compare STP versus UTP, there's an active debate on networking community as to which product is superior. I think fiber optic is. All right. So it depends. What are the applications? Again, one common recommendation that I always give is that you never invest $1 million to protect or to protect something that is worth $1. So keep it within the ballpark. Uh, if you only have one connection, do you really want to invest $10,000 in a connection? No. There's other technologies. Just be mindful. Just uh, uh, be kind with the resources that are not yours. Okay. Stewardship is the word comes to mind. So we're going to be aware of stewardship. Uh, we're only going to apply the technology that is required, not the one we want. It's not our money. All right. So yeah, there's more fluff about this, but there's there's various limitations. It's kind of like treat them the same. Uh, Bottlenecking is when you have multiple computers trying to access a single computer through a slow cable or slow connection. Uh, so that's when you get bottlenecking. Right? Full duplex communication is when you are capable of sending and transmitting and receiving data at the same time, and that's done on a gigabit Ethernet, where it uses all 8 cables or 4 pairs. That's why it goes a full gigabit, because it's full duplex. Half duplex is you receive at one time and you send at one time. All right. So I'm gonna upload the rest of the presentations because there's a lot of slides on how to do things, and it basically goes over uh, this. I'm not gonna tell you look at this, look at this, look at this, and read that. No. Just I'm gonna upload this presentation where it has how to do the different patch cords and the different uses. So this is pretty much straightforward, and so I'm not gonna read the slide, so you guys can read. If you have any questions, we could arrange something. So keep me posted. Send me an email, text me, or anything else. All right, take care, guys.